Hello and welcome back to day 2 of our 8th Streaming Media Connect. We're going to be back in person in Huntington Beach for Streaming Media West in November. And the program for that just went online. Check that out at the link that our producer, Steve Nathans-Kelly, is going to pop into the chat. Registration is open, and if you're interested in speaking, please don't hesitate to reach out to me. Between in-person and online, we're doing 4 conferences a year, 2 in person, 2 online. So it gives us a great chance to stay connected in the real world and virtually. I am Eric Schumacher Rasmussen. I am the conference chair for streaming media events, and I'm also the CMO of Ideas. Before we jump into our panel, a few housekeeping notes. Just for being here, you're entered into a random drawing to win an Amazon gift card. We'll announce the winner at the end of the panel, but you must be present to win. If you have questions for our panel, please put them in the Q&A box at the bottom of your screen rather than in the chat. The chat will be open, but we prefer the questions in the Q&A box just because it makes it easier for us and our moderators to keep track of them. Also, you'll notice that live subtitles are turned on. If you want to turn them off, you can go to the button that says Live Transcript at the bottom of your Zoom window and select Disable Transcript. Finally, all of these Streaming Media Connect sessions will be available on demand starting Monday at our YouTube channel. And once again, Steve is going to put the link to our YouTube channel in the chat. None of this would be possible without our sponsors, of course. And so I'd like to thank our diamond sponsor, Media Silo, for bringing all of these sessions to you this week. And we've got a brief video message from them. I would also like to thank the sponsor of this session, Visionular, for sponsoring and joining us. It's going to be a great discussion. It's about a topic that is still at the core of everything we do in this industry, and that is video codecs. So y'all know why you're here. We've got some great speakers, and I'd like to introduce our moderator, Jan Ozer, and ask Jan and our speakers to turn their cameras and mics on now, and Jan will introduce our speakers. Jan, how you doing?
I'm good, Eric. How are you?
I'm great. I'll let you take it away.
Thanks. We've got a really distinguished panel today, and I want to briefly go through their experience with codecs and streaming so you can get a sense of what they're bringing to the table behind the conversations that they'll share. So in politically correct alphabetical order, Thomas Davies is a distinguished engineer at Visionular, which I just mangled. Eric's pronunciation is new to me, where he is directing the development and standardization of the company's codecs, including HEVC and AV1. In his previous position at Cisco, Thomas led the deployment of AV1 in the WebEx video conferencing product line and was the principal and developer of the world's first real-time software HD AV1 encoder and a major contributor to the AV1 standard. Also at Cisco, Thomas participated in the HEVC standardization process and in the development and optimization of real-time HEVC and H.264 codec solutions. Andrey Norkin is a senior research scientist of video algorithms at Netflix and the co-chair of the Alliance for Open Media's Video Codec Working Group. At Netflix, he coordinates the company's contributions to AV1 and particularly SVT AV1, and has contributed to high-profile AV1 features like film grain synthesis and the HDR video pipeline. Andrey also spent time with codec development with Ericsson, where he supervised researchers working on video algorithms, and is a senior researcher and standardization delegate for MPEG and the ITU. Behnam Kakavand is the video R&D lead engineer at Evolution Gaming, a leading B2B solution provider for casino operators that offers a live casino, live game shows, and other highly interactive programming. At Evolution, Behnam designed, prototyped, and helped implement the company's end-to-end streaming architecture, which is a role he's played with many previous broadcasters in his past. I saw Behnam's work up close and personal when I reviewed his incredibly thorough testing of SVT AV1 encoders for real-time applications. David Ronca is the director of Meta's video processing team, where he is responsible for video products like Instagram Live, Reels, and Watch. Prior to Facebook, David spent 11 years at Netflix as the founder and director of the encoding technologies team, where he drove many innovations like inspection-driven workflows, complexity-based encoding, and the video quality metric VMAF. David also drove the development of the technical Emmy-winning global subtitle standard IMSC 1.1. David's current passion, which we'll talk about late in the session, is reducing the complexity, cost, and power requirements of video processing, which is a top consumer of power in today's global data centers. Finally, Kevin Yao is a global principal solution architect for direct-to-consumer media and entertainment solutions for AWS. In his current role, he works with partners to build their business from a cloud media perspective. Before joining AWS, Kevin worked at Dish as a principal architect, where he defined and implemented cloud-native 5G networks, OTT solutions like Dish Anywhere and Sling Media, and traditional DBS broadcast systems. Kevin has 20 patents granted and 24 in process relating to broadcast media and telecommunications. So that's them. Here's how the panel will proceed. First, each panelist will identify which codecs their company is using, where and why. Then they'll talk about the next codec they plan to implement, and again, where and why. And Thomas will discuss the demand he's seeing for Visionular codecs from his customers. Then they'll identify the codec that they're not going to implement in the short to medium term, and they'll tell us why. Thomas and David will update us on the AB1 development path, including what's happening with SVT AB1 and libaom going forward. And again, we'll hear from Thomas about where he's seeing customers paying for Visionular codecs rather than using open source. We'll discuss each company's plans for improving encoding efficiency and reducing its carbon footprint. And if we have time, we'll discuss their plans for the metaverse and when they see this relevant. So, let's just jump in, and why don't we start with Andrey, and tell us which codecs Netflix is using, where and why, and try and keep your answer to 90 seconds to 2 minutes.
All right, let me try that. So, well, first of all, I guess I should say that as a company that has a lot of members, over 200 million, we have to support a variety of codecs, and even some legacy codecs that we started to use at a certain point until so far as sufficient number of our members are using them for streaming. So from that perspective, I guess one of the codecs that we still support is H.264 baseline. We also support the main profile for those devices that actually support this codec. And that's more or less our fallback option if nothing else works for a customer, since you know that H.264 is probably the most widespread codec nowadays. In addition to that, we support some other codecs such as VP9, for example. If you want some better coding efficiency on mobile devices on Android, then you can use VP9 if the device supports that. We do support HVC for some TVs. For example, if you want to stream UHD video or HDR, then often that would be HVC, and we are currently working on rolling out AV1. So we do stream AV1 already on certain TVs, on Android. We stream it also on certain game consoles and even on browsers. So the support is currently growing, and that's basically our most efficient, our most advanced codec nowadays.
Okay, thank you. Behnam, what are you saying, or which codecs are you using and where?
Well, for now, we are only using H.264. There are multitudes of reasons for that, but the most important one is that some of them are legal. For example, we cannot basically provide any native app. So we are forced to and limited to make the playback in the browsers. And we chose the H.264, basically H.264, because it's almost supported everywhere. There are other reasons for that as well. we are just doing live. We don't have any VOD or pre-recorded video. And for us, RTMP is basically the thing that creates the backbone of our live video infrastructure for now. And RTMP has the support only for the AVC and nothing else. And another reason is definitely the royalties. I mean, it's much easier to not have to dealing with the royalties. As long as you are not delivering the codec itself to the clients, you don't have to pay the royalties as well. So this is another reason. And also the abundance of the very good implementations, open source and proprietary implementations and hardware and software encoders as well has been a big reason for that as well.
Okay, thank you. David, what can you share about what Meta's doing? We can't hear you, or I can't hear you. Your mic is unmuted.
I'm sorry. Can you hear me now? Oh,
Better.
sorry about that. My technical glitch. Yeah, so I think no surprise, probably amongst everybody here, the dominant codec is still H.264. And I would say that I certainly, if you would have asked me 10 years ago what the codec landscape would look like in 2022, H.264 would not have been my answer. But nevertheless, it's a faithful, reliable codec. It's got reasonable performance. It's from a computational perspective, it's phenomenal. From a efficiency perspective, it's not terrible. And obviously device compatibility is a big issue, on the, global population of mobile devices, web browsers, and connected TVs. So H.264 is still sitting in a very dominant space for us. VP9, we've been streaming VP9 for several years. It's a significant efficiency win with a relatively modest computational cost. And so we've been using VP9 both for our standard definition and for our high definition video. And then more recently, we've deployed AV1. We have partnered with Netflix and other companies to bring optimizations, mobile optimizations and web optimizations or x86 optimizations into the David decoder. And now that's allowed us to deploy AV1 playback to a significantly large population of Android devices as well as iOS, I should say a not insignificant population. When I say we, I'm really speaking about the live and video on demand use cases within, the family of Meta applications. There are other use cases. We have got Oculus, we have, the teleconferencing devices. We have other areas where codecs are being used, like immersive, where it's slightly different, and I'm not speaking to those use cases. As far as codecs we don't use, the most obvious one, when I say don't use, I'm talking about producing and deploying encodes to users. I'm not talking about what we bring into our systems. It would be HEVC, and I've spoken to this before. The cloud of uncertainty, confusion, royalty confusion still exists, particularly on the transcoding side, the playback side. The decoders were there, right, in the ecosystem, but the lack of clarity around the expectations or the IP expectations for encoding, is always been a concern. So for HEVC, our use would be relatively small, low distribution use cases, perhaps some premium videos and such, but it doesn't really have a place and never will have a place in the UVOD. We have no plans to use VVC in the future. I won't say never. I'm not saying never for HEVC either. A VVC is just not really clear what the use case would be, and let's see, 3, 4, 5 years out, if anything changes. EVC, I don't personally believe. I believe EVC is a codec the world just doesn't need. We have too many already. It's too confusing, and so it's not clear to me what the market would be for EVC. With regard to AV1, I've said this before, but and I'll just repeat it. The implementations that are available, both closed source and open source, are showing AV1 to be an incredibly robust and efficient encoder with really, really solid computational efficiency as well. And so we're really, really bullish on AV1 over the next few years.
Okay, you just answered 3 whole questions. So we'll come back to you in a few. Kevin, what do you got for us in terms of what your group is using inside of AWS?
Yeah, so I work with more than hundreds of AWS partners, and they're both coming from either the traditional broadcast side versus streaming. So I think before we talk about encoder, I think it's important to talk about decoding as well. And right now, in my view, in the decoding realm, there's breaking up to hardware ASIC-based living room premium content decoding versus software-based, browser-based encoding. So, you know, to answer the codec question, I think it's helpful to understand the why. So I will take about 30 seconds and go back past few decades and paint a picture and see how we get there. So when this digital revolution all started, it was switching from analog to digital by the telco and cable operator. The pace was much slower than today. You know, at the time, fiber infrastructure wasn't completely there. We have Blockbuster on the corner, and Netflix was a startup mailing DVDs. So since mostly decoding at the time was driven by hardware, and the slow adoption takes decades sometimes to go through. So every time there's a change in codec, the operator or broadcaster will simulcast, will broadcast both channels in the old and new codecs, and then it will send out a technician out, and the customer have to take a day to wait for the technician to arrive to come in and change out the equipment. And in some ways, the traditional broadcasters is still thinking in this way. It's slow. The operator has to go door by door, and many years to go from MPEG 1 in the early 90s to MPEG 2, then H.264 to AVC. And even currently in certain part of the world today, MPEG 2 service is still being deployed. So back to your question, for today's broadcast world, they're still dominated by H.264 and AVC, and that's primarily due to hardware chipsets in the devices and their legacy systems, followed by HEVC and MPEG 2 as the main consumption. On the other hand, with OTT and direct-to-consumer, most of them are software driven, so it leads to a faster innovation and shorter adoption cycles. You're less bounded to hardware and could easily add features into your pipeline as long as there's decoder support. So with cloud, you could quickly spin up down the encoding cycle and scale based on demands. However, due to this low entrant and not limited by the hardware requirements, I see there's a lot of fragmentation in this multi-codec world. And with the speed of increasing and accelerating, this fragmentation as well. So currently we have AV1, VP9, HEVC, H.264 AVC, and some other formats as well.
Okay. Thanks. Thomas, what are you seeing? And what are people looking to implement now that they may not have been using in the past?
Well, we have 3 main codecs in our product lineup. We have H.264, HEVC, and AV1, and we're seeing I think a definite trend to move away from H.264, but there's still robust interest in it because of the kind of system constraints and client constraints that other panelists have talked about. There is some growth in interest in HEVC. Actually, it's not completely dead. Some people were able to work around those uncertainties, but fast coming up on the rails is definitely AV1, and we've seen a good growth in customers deploying real AV1 solutions. We haven't seen any interest in the other codecs that people have mentioned, like VVC yet. it's definitely AV1 that's the fast growing codec at the moment.
Okay. Any particular applications, top two or three that you're seeing?
It's a mixture of VOD, some interest on live streaming, and RTC. So if you think about where AV1 is giving its big benefits, having screen content as part of the main profile is a big win for RTC. So there's a lot of interest there, and that's about, I would say, about half of the AV1 customers are going for RTC. And then on the VOD side, there are tools like film grain synthesis that is very interesting to people and can really produce huge reductions in bit rate. So those kind of technologies are helping to drive adoption. The headwinds really are, getting a complete suite of hardware support and support across all the browsers and all the OSs, so that there's been interesting rumors recently about what Apple might do to help complete the picture and then accelerate things still further.
Okay. Behnam, what's codec next for you guys?
Well, for now, AV1 is the thing that we are both testing, and we are very hopeful that it will be the thing that we are going to use. There are reasons for that. Mainly, there's no royalty. You don't have to deal with any headaches of the royalties, but and the very complex schemes there. And also the fact that we are seeing that the very big names are actually supporting it, or getting behind it. It gives us hope that it will be something that's available in almost every device out there. Every device can actually use it and decoding it efficiently without draining the batteries or setting the mobile phones on fire. And we are saying, as David said as well, we are saying good and promising performance out of it. We've tested almost all the available software, the encoders out there, including the Visionulars, Aurora 1, the SVT1, Ravi, and LibUM. And so far, only two of them are capable of doing the live, the Aurora 1 and the SVT1. SVT, especially in the latest two versions, 1.1 and 1.20. And it's promising, but I'd say that there's still time left for it to become more mature. It looks like that all of the implementation, especially the open source ones, are targeting the VOD and not the live use cases. And that is something that we are hoping to see improvement there, namely the encoder latency. It's something that we see that is actually something that we cannot use. For example, with the SVT AV1, the latest version 1.2.0, at the preset 11 or 12, we see around like 500 milliseconds of the latency and encoder latency, which for us that we are fighting for every milliseconds to reduce our latency, that is not acceptable. And comparing it with like 40, 50 milliseconds of the latency on the X264, that is a lot. I mean, half a second or more. If you go to, for example, the preset 9 and 8, it easily gets up to 700 milliseconds on average, and not even the max. So for now, AV1, we have our eyes on it, and we are thinking of even going after that. I mean, after AV1 is in place, maybe LCVC as added benefit on top of the AV1 could even help reduce the bit rates, saving the bandwidth, or increase the quality even further. Right now, we are seeing again at these presets of 11 and 10 and 11, we see around 20% of the bandwidth, between 20 and 25% of bandwidth saving, depending on the type of the content. And some other contents, there's actually no saving. I'm talking about the SVT, actually. But it looks like that it's going to be there. And yeah, we are hoping to see even further improvements on both the AV1 implementations and as well as the LCVC.
Okay. Andrey, looking at looking at the new codecs from MPEG, I guess LC, VVC, and EVC. What are you thinking about implementing those in the next 6 to 12 months or whatever period you think is relevant?
Actually, we are currently not looking into that, and the reason is that we are currently still rolling out AV1. That means for a company, when you're rolling out a codec on scale, then it actually involves quite a lot of work. So first of all, you need to certify the devices to check that they support codec on the content that you encode, and then you also need to encode your catalog. You need to invest into encoding recipes to find the best way to compress with this particular codec, to choose an encoder. So we're still in progress of rolling out AV1 for the majority of our catalog, and the number of devices is growing. And basically, we are currently invested in that, and we are not looking at the moment into implementing some of the newer codecs. One thing that we are looking into is actually rolling out AV1 with HDR content. So far, it's been SDR mostly, and that's our next step. And when we are done with that, then I guess we are going to reevaluate and see what we are going to do further.
Okay. Can everybody hear me? Because I went silent.
Yeah.
Okay. Thanks for that. Kevin, do you have anything to add to that? I guess you're looking at more the decoder side first to direct which new codecs you're going to be implementing.
Yeah, exactly. In my partners' work, we have more than 400 AWS partners against 5 solution areas, including direct to consumer. So when I'm working with partners, it really depends what end customer wants and their unique geographic region worldwide. So we have to look at all options. We typically work backwards and start with the ecosystem support and towards their massive adoption of codec as a starting point, because managing multi-codec is very challenging and it's very costly. So most of the time, my partners and customers, they get towards 1 or 2 codec based on the customer requirements, and they want to be widely reachable as possible. So if you're the end, if it doesn't matter how efficient your encoding is and how awesome it is, because at the end, if your customer cannot watch your content, it just doesn't matter. In terms of codecs, so again, browser-based, I see a lot of them go with H.264, VP9, AV1. Next 5 years, I see AV1 continue to grow, AV2s around the horizon as well. And we'll see how the licensing turn out for VVC. If you're in a living room watching on the big screens, then still predominantly HEVC for smart TV for 10-bit HDR support, to some extent VP9 for Android TV as well. And in the next 5 years, I see AV1 or even VVC taking up interest.
Okay. Thomas, what are you looking at? First of all, how do you say Visionular?
Visionular.
Visionular. So you guys have to take bets on codecs, it sounds like. So you've took a big bet on AV1. Are you looking to take more bets on newer codecs, or are you just going to see how much you can leverage AV1 develop?
We're definitely monitoring the situation. I mean, I think it's still very early days for VVC, to be honest. I mean, there's a lot of, when you have something standardized, there's a lot of noise after it as people start releasing various, open source implementations and so on. But really, the hardware needs to be there, and the licensing certainty needs to be there. I think some analyses have suggested that only maybe a quarter of patents are patent holders are in the pools. So there's a great deal of uncertainty about VVC. And to be honest, when we talk to our customers, VVC does not come up very much. I think when we see an uptick in that, then we can start to invest more in that. And yeah.
Okay. David, you've talked a lot about the decoding side, and I think you've you've been in public talking about how the AV1 hardware implementations have been a little bit slower on mobile devices than a lot of people expected or would have liked. What are you seeing on the decode side? Apple hasn't adopted it yet. Does that mean you can't decode AV1 on Apple devices? And what are you seeing performance-wise with software decoders on Android devices that don't support, they don't have hardware yet?
Yeah, thanks. That's a good question. I did want to just put in a general comment that I believe the ink was dry on the HEVC spec in early 13. And I remember at Netflix, we shipped our first 4K on Valentine's Day 2014 on HEVC enabled TVs. That's how fast HEVC moved, right? And we can use that as a measuring stick against both AV1 and VVC. The world's moving much, much slower on this next generation codecs. There are probably many reasons for that. Perhaps one is just that the HEVC enabled capabilities that didn't really exist very well in H.264, such as 10-bit color and more suitable for 4K. So perhaps that's why everybody moves so fast, the new feature set, and perhaps AV1 and VVC don't offer those. They just, increase compression efficiency. But it is an observation, I think, that things are moving slower. I think the market is considering these new codecs at a much slower pace. AV1 has moved slow. I mean, many years ago, a colleague and I had debates about when we would have good, reasonable penetration of hardware codecs in the mobile space. He insisted it was 2020. I said, no way, it'll be 2022 before we have really any good penetration. Well, here it is 2022, and it's still not there. That's the half empty side of the cup. The half full side of the cup is we're seeing from all the chipset vendors that for the Android side that AV1 will be in the next generation, and it always starts at the premium tier of chips and then works its way down. So I expect by 2025, pretty much all new Android phones being sold around the world are going to have hardware decoders. It's been much slower than we wanted, but it's still a good outcome. I have no idea what the other royalty bearing codecs, how they will play out in terms of time to market. In the meantime, we've invested a significant amount of money in software decoding. There's two good software decoders available. There's David that's available through Video Labs, and then there's GAV1 that Google has produced, and they both deliver solid performance on Android devices. You can run them a software decode on an iOS as well. I have no idea what Apple's plans may or may not be for hardware or long-term AV1 support, but we're finding that David and GAV1 both perform very well on x86 and on the ARM family of devices. So in the meantime, we're actually able to deliver 720p and 1080p to a significant set of users and in our applications, and we're very happy about that. And we're very happy with the results with SVT-AV1, which we invested in partnered with Intel and Netflix. The ability to turn down the computational complexity has been very beneficial. Allows us to kind of tailor find the right cost benefit value for any given video.
Okay. Andrey, why don't you switch hats for us? One of the things that confused me with, some of the announcements coming from the Alliance for Open Media was that it looked like you were focusing on SVT-AV1 to the exclusion of libaom. So why don't you take a minute or two and talk about what the development plans are for those two codecs going forward?
That's a good question. And I cannot say that there are any exclusion plans for any of these two codecs. It's just that they are both used as reference software in two different working groups in AO Media. So there is a video codec working group that works on developing new video codec specifications, and basically LibOEM is the reference software, and it is still a reference software for AV1 codec. And moreover, currently the group is working on the exploration beyond the AV1 capabilities, and there is a software called AVM, which is basically a descendant of LibOEM that is currently is reference software for these efforts on the compression beyond AV1. So and still LibOEM, the main branch still remains basically the reference software for AV1. Then SVT AV1 is the reference software for the software implementation working group, and that group focuses on delivering production grade software, where SVT AV1 basically fits in. So SVT AV1 supports very good parallelization, and it's also pretty efficient. It supports multiple encoding speeds, like ranging with a very significant range between the fastest and the slowest presets. So and that's basically the reference software for that group. So both softwares are being developed, and there are plans to continue with both of them. And even some other spin-offs, basically covering the new research on the new generation of codecs.
Okay, Thomas, when do there's open source and then there's for-fee codecs like yours. What applications and why are people choosing to use your codecs as compared to open source for either H.264, HEVC, or AV1?
Well, for AV1, I should say, we have a unique situation, and we're very lucky that there are two very good open source implementations with generous licensing that you can look at, and that's raised the whole bar for the whole field of paid for codecs as well. I mean, our customers are looking at the holy trinity really of speed, quality, and bitrate, and so a different customer will have a different trade-off between those things. Often you're trying to get to a new resolution, a new application, and you can't do it at the bit rates that you want to, at the density that you want to. So we see ourselves as getting a big premium over the open source solutions in those dimensions, but which dimension you get the premium in depends on how you want to tune it, how you want to trade off speed versus quality versus bit rate. So for some applications, you're really very interested in density, and that's related to speed, but it's about packing the largest number of transcodes or encodes into a server to reduce your carbon footprint, to reduce your costs, and so on. So that's what they're really coming to us. If these elements of the Holy Trinity are really critical to your business, and you want the extra speed, the extra quality, or the extra savings of bitrate, then that's what you pay for, and you come to people like us, hardcore video codec group of developers who are really focused on optimizing for these different use cases. But our customers do range from the very high end FOD case, where you are looking at encoding at 1 FPS or slower, and then there are sort of the mid-range 3 to 5 FPS, suitably parallelized across a server necessarily, and then at the other end you move to RTC use cases where you're trying to actually provide not just real time, but much faster than real time, because you'd like to use a fraction of a CPU, not a whole CPU, in many RTC applications. So you have to support a very wide range of operating points, and hit the sweet spot in each one, depending on how the customer wants to balance those things.
Okay.
Can I add a few words to that?
Yes.
Yeah, so I'll say that, SVT AV1 is a very, very good encoder implementation of AV1. It kind of the fundamental level It's production grade, but it's not. There's a lot of capabilities and features that are not there, and the intent was never like, let's just have one codec that everybody would use that does what they need. The intent is really to seed the market with like a very good baseline, and the terms of it are such that you can use SVT AV1 or libaom code is in an AV1 encoder, right? You can make a closed source out of it. So I think that Visionular and others are showing, that there is a real value in closed source. In fact, we use closed source codecs in some of our use cases as well, because of the capabilities they put on top of that baseline. So SVT AV1 is an incredibly good baseline for a production grade encoder, but there's a lot of things that could be done there that never will be done. And it's really up to the Visionulars of the world to take that baseline, a codec, and turn it into like, that tier 1 production grade.
Good, thanks, David. Kevin, going back to you, let's turn our attention to greening and carbon footprint and carbon emissions. What are you hearing from your developers, and what are you hearing from inside AWS in terms of the importance of attempting to address that from a codec selection standpoint?
Yeah, that's a very good topic. I mean, if we look at video, it accounts for over 60%, if not more, downstream traffic on the internet. There are a lot of energy resources being used for encoding and decoding the content. And in addition, we have to consider how much energy are used to deliver those content across fiber to end users. So there's some optimization done, whether by caching at the edge or just-in-time encoding for the tail-end VOD services. Things like we could have cloud encoding instances use less energy by right-sizing the instance type by machine learning, or we could have content-based encoding combined with AI/ML to predict what type of content during what time of the day that each household most likely to stream. So Saturday morning cartoons, for example, or Sunday night football. But drilling deeper into encoding, at AWS, we have Graviton processors, which is an ARM64-based processor. And to help customer reduce their carbon footprint, Graviton 3 was announced, and Graviton 3-based instances use 60% less energy compared to the same performance to the x86 EC2 instances. So for a quick test at last year's AWS reInvent conference, we ran X264, a very slow preset input with uncompressed 1080p material. We see about 49% per frame per second compared to the previous gen C6G to the current gen Graviton 3 C7G instances. But if we go back a level and talk about sustainability in general, workload running on AWS are 80% more carbon efficient compared to running at our customer's own data center. And as part of our commitment to net zero carbon future, we're investing more power into our operations with 100% renewable energy by 2025. So combined with a higher computing price performance and improved power efficiency, I really encourage folks to look at other processings such as ARM to help reduce carbon footprint and their costs.
Okay, David, I know this is near and dear to your heart. What do you, and talk specifically about, either codec selection or codec encoding like Kevin did. What do you see happening?
Yeah, I mean, as Kevin mentioned, right, the parameters we're interested in, we'll just say energy consumption, we want to reduce bits, and we want to reduce distortion, right? And in a system, generally speaking, a video system, you push 2 of those down, the third one goes up, any 2 of them, right? And so the answer is, we have to redefine the system to to lower the baseline that we're working from. And I'm intrigued by the results that EC2 is seeing with ARM. Definitely from our side, I think custom ASICs generally in the past have always been thought of as low quality but cheap from a power consumption perspective. I think that's going to be turned on its head over the next few years. We're investing significantly in ASIC-driven processing, and the very happy with the qualities we're seeing, and we're going to continue to push that. We've seen other, Google, for example, has released white papers on the ASICs they've deployed. So I think there's a role then for ASICs as well. So this gives us an opportunity, I think, across multiple dimensions to actually reduce the inherent complexity or the fixed complexity of the systems, so that we can continue to reduce, reduce the energy consumed. And I think it's good that we're looking to clean energy sources, but I think the other side of that is, with continued increase in complexity, with new things like bringing in ML and all kinds of analysis, video is very, very computationally expensive, and generally speaking, pretty dirty in the terms of energy consumption, and use around the world. So I think we do all have a responsibility, and I think that the industry is very serious about that. And I'm really happy with the work that I'm seeing. Again, everything from lower power CPUs to ASICs and more efficient codecs, which again, I'm gonna plug SVT AB1. The energy, you basically have a dial you can turn, so you can select the energy cost of your compute to do an encode based on the likely value that video will provide in the market. So, you can bring it down to compete with X264 very fast while still significantly reducing the bits. And so to me, these are all great things, I think, that we're all aware, we're all of the power consumption problem of the data center growth, and we're all working on it. And I'm excited by what I'm seeing.
Andrey, what are you saying?
Just quickly add to what David said. Currently with our encoders, we have fast encode preset, quality encoding preset. Perhaps in the future, we have a green encoding preset as well.
Andrey?
All right. So actually, Netflix has been looking into the carbon footprint, and we have also invested in some external research done. And for example, there was a white paper published recently on the carbon footprint of streaming from Carbon Trust. And basically what you can figure out from this paper is that often the majority of the carbon footprint can be attributed to actually the user or the member devices. So like, for example, screens. If you look at the global compared to the encoding, at least that would be true for us. I think we have somewhat different profile for encoding than, for example, Meta has, in a sense that Meta may need to encode a lot of videos that almost nobody would watch, and they would need to differentiate between those videos and the most popular ones. But for us, we typically encode things that are watched multiple times, and sometimes even millions of times. So for us, I think from this perspective, it makes sense to invest into encoding the content, encoding it, spending more cycles on encoding, so that we would spend less time when basically deploying the content on the CDN and then distributing it to our members.
Okay, thank you. We'll hold the metaverse in abeyance for a second. I want to address some questions from the audience. One for you, Behnam, is there's hardware AV1 encoding out there now. When do you start to look at hardware as an option as compared to Visionular and SVT AV1?
Well, there's a reason that we like the software encoders, and that's because of all of those bells and whistles and buttons and knobs that we coming with the software encoders. So we can tune it, since we have the full control over the input content, and we know beforehand what it is, and it's pretty repetitive. Nothing much changes in that. So we can technically, practically tune the encoder to the very specific output, receiving a very specific quality and a specific bandwidth, which is usually the bit rates that we have to tune into for is coming from the business side of the thing, that the limits imposed on us. And receiving something like that with the hardware encoders, even with the current AVC hardware encoders, it's not much possible at the exact same bit rate. It doesn't produce the exact same quality as a good software encoder. In case of the AV1, that is one thing, but the other thing is that we are right now at this point still relying on the RTMP to delivering anything to the edge servers and to the basically distributing the video worldwide. And we are in the process of changing that. So practically at this point in time, using the any other codec like the AV1 is not possible for us. But in future, we may try it definitely and see how it is that these hardware encoders are working. But to be honest, I'm still pro the software encoders because all of those granularity of all the tunings that you could do.
Okay, thank you. There's been a few questions on the whole royalty conversation between some of the MPEG codecs and AV1 codecs. I just want to remind the audience that these are engineers, not attorneys speaking, so I wouldn't draw any conclusions about royalties or non-royalties based on what they're saying. Next question is, let's jump into the metaverse. Can we, talk for about a minute apiece for anybody who's got thoughts on that? David, let me start with you. When's that going to be relevant, and which codec is going to drive it?
Well, I mean, the metaverse, I think, means a lot of things, different things to different people. I think if you ask 5 industry experts, you probably get 5 different answers. To me, it's really immersive and interactive, right? 2 things about metaverse. And to me, the ultimate metaverse would be a holodeck. For anybody who watched Star Trek, The Next Generation, I think we're a long ways away from holodecks, but to me, that's like the ultimate in metaverse experience. Between then and now, I mean, now and then we're moving from kind of mostly a passive, you put on, well, I mean, actually, I think I should back up. Game players, a lot of game players are playing with AR, VR headsets, are already kind of in an interactive metaverse. It's just a metaverse that a lot of us are not, that aren't avid game players are really part of. And in that, I think the use cases for the broader population, education, interactive teaching. I mean, right now, distance learning is very passive. You have a speaker, you have, watchers. Imagine, being in a virtual classroom, being able to take virtual tours, doing other things. So, I mean, these are like the future of the metaverse that are very exciting, but they're also quite far away. From a video perspective, I think of it more in the technical terms of what has to be done, to enable that. And I think there's a significant amount of work that has to be done in order to build the technical framework that can support a true interactive video experience, immersive interactive, and so I think that's, you look at it, there's work happening across both in AOM and both other standardization groups. There's work happening to try to start driving some standards for, bringing objects into an immersive video experience and being able to interact with objects. So, I mean, it's a long ways off before we're all going to be, having these sorts of events in a virtual world, but it's also exciting.
Okay, Behnam, you're probably closest to this today, or I don't want to say closest, but you're certainly close to it. What plans do you see going forward or what does the metaverse mean to you from a definitional and a codec perspective?
Well, let me put it this way. We actually started experimenting with the VR Live product and streaming. And we added one VR game, although due to the nature of this game, which requires interaction on top of the VR and the number of people who actually own the proper headsets to use them, it's very limited at this point. But we started playing around it to prepare for that world, basically, and creating immersive experiences for our players and users. And what we found out was that we are in need of very, very high bit rates, just to put it in plain technical terms, and very, very high resolutions in order to create something that remotely resembles like a maybe a realistic experience. it's very easy to see all the defects and the bad things on a headset when it sits so close to your eyes. And so for that, we are definitely in need of a more efficient, from the video side of it, more efficient codec that can do up to 8K, I don't know, even maybe higher, that can create a crystal clear image without any artifacts, and those kind of artifacts can very fast and easily destroy the user experience. And so absolutely higher and more efficient compressions is an essential thing for anything remotely immersive being something usable for the users as well.
Okay, Andrey?
Well, first of all, a disclaimer that I wouldn't be speaking from Netflix perspective, because our focus is currently streaming, at least in the team that I'm working at. But if I speak as a codec engineer, like what's required for the metaverse, then I think it depends on how you define it. For example, if you want to stream 360 degrees videos, then you obviously need high resolutions. You probably would also need to have some support from like tiles and also pretty fast encoding presets. If you look a little bit further, then maybe one of the things that you need, and I think it was mentioned by at this panel already, that you probably want to look into the objects, encoding objects in video, and probably this is one of the things that would need to be developed for that to be successful.
Okay, Thomas, real quick, and then Kevin, I'll give you a chance to close up for us.
Yeah, so one thing that hasn't been mentioned, I think, is latency and resilience for these kind of applications. You've got vast amounts of data that you have to distribute real time at very low latencies for people to interact with. And that leads me to think, oh, maybe we should be looking at solutions that involve some kind of decoder side synthesis for a lot of these things, that maybe we should have a less distribution oriented view of these kind of interactions. It seems to me that the standards of actually what define the metaverse and the interactions you have in shared universes are not really there. We're still feeling our way on the basic technology. There's lots of good prototypes, I would say, that sort of work, but I think it's not even clear what kind of compression is really needed. We can compress the video streams that we have for the prototypes that exist, but whether that will really give you the fully immersive, richly detailed, resilient, low latency experience, I'm not sure.
Okay, Kevin?
Yeah, Thomas was going to say what I was going to say. Latency, I think it's a very important factor. I think currently with streaming and broadcasting, we can go away with a couple seconds. That's fine. But in Metaverse, if you were to turn or to move, you can't wait 3 seconds later and have the image to show up. That's just gonna destroy all the immersions. But if you look at that in whole, there's all kind of metadata going around it in addition to codec, and with that comes storage capacity, compute capacity, database, machine learning. All of those need to be worked together to create a very compelling user experience. So I think we're still quite a bit away.
Okay. Listen, I just want to thank the panel for taking the time today and the prep time. It's been really interesting for me, and I'm sure it was for the audience as well.
Thanks so much, Jan, and thanks again to all our panelists. Thanks also to Visionular and Media Silo for sponsoring. The winner of the Amazon gift card for this session is Tess Decker. Tess, keep an eye out on your email. You should get an email next week regarding that. Next up, I will be moderating a session on cloud versus on-prem versus hybrid workflows. So we'll see you again in about 30 minutes. Thanks again, everyone.